Welcome back everyone. In today's video, sentiment analysis using Navie Bayes. So these are all the topics we will cover today. Hello everyone. Have you ever wondered if a computer could actually tell if you are happy or sad just by reading your text? Today, we are diving into the sentiment analysis. We are going to teach a machine to detect human emotions in movie reviews and tweets using a very clever algorithm called Navie Bayes. Let's get started. So, before moving ahead, you can see there are some particular sentiment of a human being. There is negative, positive, and a neutral one. So, we will train our model about all these three and more sentiments, then we will check how our model is working. Sentiment analysis. Sentiment analysis is basically giving a computer emotional intelligence. Its job is to look at the statements and the sentences and decide the vibe. Usually, we categorize text into positive or negatives. Businesses love this because it lets them scan thousands of customers' reviews in seconds to see if people are happy with their products. Ahead, why are we using naive bias? Because it's a speed demon. It is incredibly fast and works surprisingly well with text. It uses probabilistic calculations that odds that a specific word belongs to a good review versus a bad one. It's a classic tool that every data scientist has in their pocket. This is the formula of our classifier, naive-Bayes classifier. There are different probabilities. This is called the probability of A happening when the B event is already occurred. And this is the vice versa. And there's the multiplication with the probability of A and whole division with the probability of B. So this is our basic formula on which our model is working. So moving forward to a computer. Sentence isn't a beautiful piece of literature. It's just a bag of words. We throw the grammar and the sentence structure out of the window and just look at the individual words inside the bag. If the bag contains words like love and happy, the computer start to suspect that the sentence or the sentiments in the sentence are positive. Just here you can see this is the example. We have the whole script or the whole sentences, but we only uses or check in the bag of words is the words are positive or negative. Here's the example. In the bag, we have I love this movie. So we will check every word and see their intentions or sentiments behind them. How the math works. Here is the secret. The model learns through counting. If the word great appears 100 times in the positive review, but only twice in negative ones, model assigns great a very high probability for being positive. When you give it a new sentence, it multiplies the probabilities of all the words together to see which sentiment wins the math better. Here, this is how our model is working and selecting which word is used for the positive sentiment and which is used for the negative ones. Moving forward, so why do we call it the name? Because it assumes every word is independent. In the sentence, not good, the model does not realize not is changing good. It just sees two separate words, even though this assumption is technically wrong and naive. The model is still incredibly accurate at predicting the overall mood of the text. Ahead with this, we reach to our step first, data collection or data acquisition. First, we need data. We use a labeled dataset. This is a collection of thousands of reviews where a human has already marked them as one for positive and zero for negative. This is our model's textbook. It's what it uses to learn which words are associated with which feelings. So this is an out structure how our model is going to be used. Our model is going to be trained. The process first the data is collected from the sample population, then it is checked on the actual population, and these are all the points where we will check our model. The accuracy, the equality, complete, and the capabilities. So before moving forward, let's jump to our Jupyter notebook and start coding side by side. For this, simply type Jupyter. Here you see codes, create a new Python file, and here name it as Navie Bayes. Simply name it as Navie. Here we go. We start with importing necessary tools. So first we will use import from sklearn sklearn dot feature extraction dot text. We will import count, count vectorizer and then from sklearn again, and in this from model selection we will import train test split for splitting our dataset for training and testing part. Then again from sklearn Nave underscore Bayes. We will import our mul- multinomial and B. Nave Bayes. There we go. And then we will import from sklearn dot matrix. We will import accuracy score underscore score confusion matrix and classification report. And last, we will import pandas as PD and simply running this is import. Here we go. Import sklearn. There are some spelling mistakes. Oh, oh, this I did not. Here we go. Here you see, it worked properly. Now it's time for data creating. We will create our, oh, let's create a small and simple data set for movie reviews. Okay, we will create a small and simple so you all can work on it and understand it quite easily. And in this, we will use some sentences. I love this movie like this. It was fantastic. Some more. Plot was boring and slow like this. We will add some more sentences in this with different emotions, different sentiments, amazing acting, and a great story. I think we need few more for this. One we'll use one negative sentence here. Worst film I have ever seen like this. And just a second, how many we have to stop? One, two, three, and four. Okay, we will use some more. I really enjoyed. Okay, I forgot. Note the characters and not good, very disappointing, and we'll add few more, just like that. Superb direction and cinematography, and we will use one more sentence here, the last one. How many we have done? One, two, three, four, five, six, and seven. I think we will go with one more, the last one. We will use terrible script and bad acting. I think 8 are good enough. So one more comma here, and we will add sentiments here. Firstly, we will work with two sentiments only, positive and negative one. So the second, just a second. The first one is positive, as I love this movie. It was fantastic. Then second one is the plot was boring and slow. So we will put that zero here. And next one is amazing acting, good story, one again. Then worst film ever, zero. Then we will check it. I really enjoyed one. Not good, very disappointing. Not two. Just zero again. Superb. Okay, one. And the last one is zero. We have done the sentiments in proper sequence. 101010. I just randomly dropped some sentence, but they came in proper pattern. One and zero. Here we are using one for positive and zero for negative. I should write the whole so that you can easily understand what's going on here. Now let's simply convert our data type or the data set into data frame. Oh, what I have done. Just a second. If equals to pd dot data frame, and in this we are using data. So now we will print. This is our data set. This is our data set. Print df. Simply running this. So here you can see these are all the reviews we have in our data set. Like, I love this movie, it was fantastic, and the sentiment is one. Here we use one for positive, So the sentiment is positive here. And like that, the plot twist was boring and slow. So the sentiment was negative. That's why we had used zero here. And similarly, all the eight different review statements. So before moving forward, let's get back to our presentation and see what is next. What are the next steps we have to do in our model? Let's go. Here we are. Let's move forward. Cleaning the text, the pre-processing. Raw human text is messy. To help the model, we have to clean it. We change everything to lowercase so that happy in the uppercase and the happy in lowercase are treated as the same word. We also strip any punctuations like commas, marks, and dots because they don't help the maths and as much as the words themselves do. So let's jump back to our coding part and clean our text. Here we are. Now we will clean our text, the cleaning and vectorization part. So let's clean first. Now we'll create a variable vectorizer, and in this we will use count vectorizer. In this, first we will create a variable vectorizer, and we will use count vectorizer function in this. And for the parameters, we'll use top words like English. And then we will, and now we will turn the text into numbers. Simply, we will use different variables. We will use x for this, and here we use the vectorizer dot fit transform to transform our type. We use the reviews here. We use the review column here for our x variables, and for the y we will use simply the sentiments. We have transformed only the review part or the review column as this is present in English, or we can say in string format. Now we have converted the words into text, or sorry, numbers, just like our sentiment is present, so that we can easily use mathematical function on it and train our model. Then we will use that model for the prediction part. So moving forward, print, and this we will write vocabulary. model, and this will use print now, and use the present get features names out, and in this we will use this function get features name out and simply run this. Here you see our model has simply separated all the words or all the action words which it has learned from our different sentences or different reviews. There are words like acting, amazing, bad, boring, characters, and there are many more. These are all the words which our model is learned from our review section. And now our model will use these different words to learn or to get trained from by using these words and get to know which word in a is used for a positive sentiment and which is not. Okay, here we are again. First, I will explain you what we have done till now, and then we will move back to our presentation part and see what next. So, with starting, we have imported all our necessary libraries and tools. There are different things like the count vectorizer, train test split used for dividing the dataset for testing and training part, and there is pandas, is accuracy score, confusion matrix, like this also. These are the things we will use for analyzing the performance of our model. So with that all, then we have created our dataset. We used a simple and small dataset so you guys can easily understand this. I wrote some random statements. Eight, I think these are eight. Yes, these are eight random statements with different sentiments. Some are positives and some are negative. And in this dataset, we have two different columns, reviews. These are all in the reviews. These are all our sentiments, all the statements. And in the sentiment column, it shows which sentiment is positive and which is negative. We denoted positive with 1 and negative with 0, like this. And then we converted our data set into data frame. Then we printed our data frame. Here you can see the first column shows the reviews. There are eight different random reviews, and the second column shows the sentiments, either whether they are positive or negative. Then we have cle- then we had cleaning and tokenization. In this part, we have cleaned our dataset and vectorize it. And for vectorizer, we oh nahi yaar, this one's explaining again. In this part, we converted the text data into numbers so that math can easily work on that and our model can work on this data set easily. So this is all the thing we have Done till now. Let's move back to our presentation part and see the next steps. Here we are. Let's move forward, removing the stop words. In English, we use words like the, is, and constantly. These are called stop words. Since they appear in a both happy or sad reviews, they don't tell us anything about the emotion. We filter them out entirely so that the model can focus on the juicy words that actually carry sentiments, like fantastic or disappointment. Here you can see a small example how our data is modified. First it's cleaned, then tokenized, then stop words removal, pause tagging, near tagging, and then streaming and lemonization. Once again forming the sentence. This is how the pre-processing works. So before jumping to coding section again, let's see one more slide and then we will go to coding section. With that, let's move. Next is tokenization. This is where we literally chop the clean sentence into individual pieces called tokens. It's like breaking a Lego castle back down into individual bricks. Once we have list of tokens, the computer is ready to start counting. Yep. The tokenization is the process in which we divide our full sentence into smaller parts to separate the words which are more suitable or which tells us whether the sentence is a positive or a negative in sentiments. So let's go to coding section and see how our model do that. Here we are. So after cleaning part, now it's time for training the model. In training the model, first we will split the dataset for training and testing purposes. So starting with this, let's create some variables, xtrain, xtest, and similarly ytrain and ytest. These four variables we will use for training and testing part. And now we will use the train test split to split the data set and do here we use x and y. With that, we use test size 0.2 as we need 20% of data for testing part and the just a second to write it down. Here we are. In this, we will use parameters x. That's our review. X is for all our reviews, the sentiments, the sentences, and then for another parameter we will use y. Y used for sentiments. Either the sentiment is positive or negative. That is, we use y for that, and then we select the test size in this. we will use zero point 0.2. We all only want 20% of our dataset to be used as test dataset and the remaining 80% for the training part. And then there is random state for starting the counter. On this, we will use 42 only, the default one, and then we will train our model. So for training our model, first we create a object here, naming model, and then we will simply putting the model in it, and then we will train it using model.fit function. Here we use xtrain and while train for the training part. You see in last we will print training is completed just to see whether our code is working properly or not. So simply run this. There is test train split is not defined, but why we have used we have, okay, we have to run all of this again. Just no worries, we will do it one by one. Here you go. Training is completed. We have trained our model. Now it's time for testing the accuracies. So, but before that, let's move back to presentation. As we know, we have done the training part in our coding section, but it is not completed in our presentation yet. So let's move back to presentation and complete all this. Then we will come here again and complete our model. Here we are, the tokenization, and the next step is vectorization, turning the numbers or the text to numbers. We have done this in our coding part, but what is it? Let's check it. Now the magic trick, vectorization. Computer can't calculate good plus great. We use a counter vectorizer to turn our words into a table of numbers. Each row represents a review, and each column represents a word. A1 means the word is there, A0 means it isn't. Now we have maths instead of text. So this is how, and this is why we convert all the text to numbers because it is important for us to use numbers to maths, to use different numbers so our model can work easily and perfectly. Let's move ahead. Now, here you see training the model. We have already trained our model. You see, so let's get started with this. It's time for training. We use a version of Navie Bayes called multinomial. As you recall that we use our creating the object, we use the version of Navis Bayes, the multinomial NB. Once we go back to coding part, I will show you again. We fed it our training data and it builds it probability map. It learns exactly which word are the strongest indicator of happiness or anger. In just a few seconds, the model is fully educated. So, this is the training part. This is how our model is trained, the theoretical part. Okay, we have already seen the practical part, how our model is trained and how it is worked before that. So, going testing the AI. As I told you, after the training, the testing part is there. Now we give the model a final exam. We fed it the test set, sentence it has never been seen before. The model looks at the word, checks its learned probabilities, and makes a prediction. This is the moment of truth where we see if our AI has actually learned to read emotions. This is the name bias classifier. This here is an example graph. Here you see there are three different classifiers and naive bias. Simply divide them all, separate them, and check which let's take is an example to our with our coding section, sentiment section. Let's take blue one as happiness. This is happy emotion, and yellow one is mm, what we call, just give it as the normal one, the normal day life going on, and the red one is the angry emotion. This is how it separates and classifies and predicts the emotions. So before moving forward and going, so before going to coding part and checking our AI, let's move to next slide and see the next steps. Here you see checking accuracy. We check the results using an accuracy score. If we get 85%, it means our model correctly guessed the emotion 85 out of 100 times. We also look at the confusion matrix to see if the model is accidentally labeling sad thing as happy. This helps us to improve our model later. So let's go to our coding section and check all of this. Then we'll come to presentation again. So here we are after training our model. Let's do testing and checking the accuracy. So for testing, we will create a variable y_predict, and in this we will use model.predict function, model.predict function, and for the prediction we will use xtest as we used xtrain for the training part, and so here we use dot predict for checking or testing our model. And before running this, we will add the accuracy also. We use or we will print accuracy separately. So here we write at accuracy report. And in this, we will use, oh, before this, print, and in this we use f string, f here, and accuracy, accuracy, and in the curly brackets we will use accuracy score, accuracy score here, and for the accuracy score we will use the two parameters y test and y predict. The y test is the original or the actual value of the sentiment, or this is the actual sentiment of our reviews, or the sent statements we have provided, and y predict is the predicted sentiment of our model. So with this, we use two parameters and we multiplied it with 100 so that we will get in percentage. There you go. We have to put percentage here. And then print the confusion matrix. Confusion matrix. There you go. Now we will print again. We will use a string here and simply matrix. Matrix oh, it's not Z, it's MA matrix here. And in this, we will simply use confusion underscore matrix. And for the parameters, the same we will use y test and y predict. There you go. Now let's check our model. First, we will test the model and then we will check the accuracies. Okay, let's run. So here you see, after the training part and the testing part, our model's accuracy is 87.33%. It's good enough. I think it can be increased if we used a very defined or a huge dataset to train our model more accurately, but I think it's good enough. So for now, let's move to next thing, the prediction part for the new reviews. So for this, we will create a function. We will create a function named as predict emotion, predict underscore emotion, and in this we will use parameter as text. So and then we use uh, parameter text vector, and in this we will use vectorizer dot transform function. Here we transform the text and we use the prediction. Then we predict the sentiments of that text, predict of text vector, and now if so, if the prediction is zero, no, the first element of the prediction is one, then return positive, as this is a positive review, and remaining for the else return negative. So it's time for test. Let's print a custom. This is custom test. Okay, so here we print, and this we are simply checking our model how it is working. So we will use a string, and we'll provide a review. This was a brilliant poem, and we will put it to prediction part, predict emotion. We will call this function here, and in this we will use this is this was a brilliant film. There you go. And similarly, we use another example, print a string, and in this we use I hate it every minute of it. There you go. And now again, predict emotion, and for the parameters, we will provide the same thing. I hated every minute of it. There you go. Let's run this. Oh, just before running it, I will explain you all this. So first, we will we had created a function in Python. To create a function. We use def, and then the function's name. We use the function's name as predict underscore emotion, and if you want to give the parameters, then you have to provide the parameters. We had used the text as we want to check the reviews. So this is the text. And then we converted the text into numbers. So the vectorizer part is here. You can see the same thing we have done here. Convert all the text part into numbers. Then we predict the using the model prediction function, predict function dot predict. We predicted the text vector, whether it is positive or negative. So let's run this. So here you see our model worked well as it's showing this was a brilliant film as a positive sentiment. Yes, it is a positive sentiment. So I think this is enough for today for the coding part. So before moving back to presentation, once again in short, I will explain you all these things. First, we imported all the important files or the libraries here, and then we created a small data set where we use random reviews and the sentiments here, zero for negative and one for the positive. Then we converted the data set into a data frame. This is our data frame. This is the data set we are using for our model. Then we converted all the English or the sentences, the text data into numbers so that maths formula can work on it easily and our model can use that. And then we also separated all the words from the sentences and we remove all the punctuation marks and the extra words. Here you see we remain with acting, amazing, bad, boring, and there are many more. These are all the words which show the true nature of our sentences or which shows the sentiments of the sentences. Then we split the training dataset. We split it the dataset into training part and the testing part. Then we trained our model, and after training, we actually predict test our model using dot predict function, and we check the model's accuracy. It's good enough. It 87.33, and this is the confusion matrix. Then we predict with random new sentences to check the statement sentiments whether the model is working well or not. So here, as we've seen, the model is working good enough. So this is all. I think this is enough. Let's move back to our presentation part. Here we are. So let's go ahead. And that is sentiment analysis. You have learned how to clean text, turn it into numbers, and use probability to read human emotions. From here, you can build your own tool to amaze movies trends or customers' feedback. You have just given your computer its first taste of empathy. Happy coding. Thank you.